Hello and welcome to the second video of the lecture series Statistics for Dummies. And today we're going to look at the normal distribution in much more depth. Yesterday, when we were looking at the normal distribution curve, we looked at it from a logical perspective. We tried to assess when the normal distribution curve can be used in daily life. And we came to the conclusion that the normal distribution curve actually represents normality. That is, anything or everything that we see in front of us, which is not out of the ordinary. And the best example for that was that of a classroom, where we see that a small amount of people actually do very bad in their exams, a small amount of people do very good in their exams, but the vast majority actually land in the middle. They actually do average. And this frequency, this high frequency, leads it leads the curve look like a bell-shaped curve. We also saw the example of a football team or the strikers in a football team, and we came to the conclusion that there are a few strikers who don't do as much as they are expected of for their countries. For example, Nicholas Benter, who scored less than 20 goals for Denmark. Whereas we also came across a very good example of strikers like Lionel Messi, Cristiano Ronaldo, Sunil Chhetri, who scored more than 40 goals for their country. But the vast majority of strikers actually land in the middle, and they are people who score between 20 to 40 goals for their country, which is neither bad, neither good. So today, when we actually look at the normal distribution, we're actually going to look at it from a much more mathematical perspective. And what do I mean by a mathematical perspective? I mean that we're going to look into what the characteristics are of a normal distribution function or a curve. And the first characteristics that we're going to look at is that it is a continuous distribution. Now, before we go into this, it's very important for us to understand what the characteristics are because it's going to help us solve those sums. If you know what we mean by the characteristics, you can easily calculate any sum in normal distribution. So what do we mean by a continuous distribution? To understand this, we actually need to understand what the area under the curve is. And to understand area under the curve, we actually need to understand what an area is. Now, if you look at a square, the area for the square would be anything lying between the borders of the square, right? And the formula for that is side squared, which is side and side. Since both of them have equal lengths, we just square it to find out the area within the square. If you look at the rectangle, the area for that is length into breadth, and we'll find out the area within the borders of the rectangle, right? Now let's look at the triangle. The formula for the area of a triangle is half into base into height, and we'll find out the area within the triangle. Now if I were to ask you something peculiar, if I ask you, tell me the area of a straight line. Now let me draw a curve to give you a much better perspective. Assume this is a curve and I want to find the area of this line, just this line. But the answer for that is the area of a line is always equal to 0 in a continuous distribution. I mean, the area is so minuscule that we do not associate any area to it. So, in a continuous distribution, the area is the probability, and hence there can be probability for no probability for exact events, right? Now this brings us to another concept in uh, another characteristic for normal distribution, which is that it follows a cumulative distribution function. That is, number two, a cumulative distribution function. or we call it CDF. What do we mean by this? Assume I want to find out the probability of less than 30 goals. Probability of less than 30 goals, right? Assuming that 30 is the central point or the absolute center of this distribution, the area under the curve would be anything below the curve up to 30, right? And this would be the area as well as the probability, right? If I want to find out the probability of less than 29 goals, 29 would lie somewhere around here. And the probability for that would be the area below the curve up to 29. Now, if I ask you to find out the difference between the probability of 29 and probability of 30, that would approximately give me the probability of exactly 30 goals, right? Now, there is a concept called approximation where we actually put 30.5 and 29.5 to find out the exact area between these 2 points, but we actually just wanted to understand this concept, and I just wanted to explain what a CDF is. So it just tells us that if we want to find out the area, we have to find out the area towards the left of the function, and that will give us the probability associated with it. So now let's look at the third important characteristic of a normal distribution, and the third characteristic is that it is symmetric, it is unimodal, and coincidentally the mean is equal to the median as well as the mode. So let us draw a normal distribution curve to substantiate this point, right? Now a normal distribution curve would look like this. The coincidental part is that the highest point, which is always the mode, is actually in the center, which leads it to be equal to the median as well as the mean. Now, the normal distribution is also symmetric, so if we draw a line to segregate the normal distribution through the middle, the area towards the left will always be equal to the area towards the right. And therefore, if the probability ranges from 0 to 1, since the area towards the left is equal to the right, this area will be having a probability of 0.50, and the area towards the right would also have a probability of 0.50, right? And finally, the normal distribution is unimodal, that is, it has only one mode, that is, it has only one maximum point. Now let's go ahead and study the fourth characteristic, which is also coincidentally the most important, is that the normal distribution follows a mean which is 0 and a standard deviation of 1. So what the normal distribution does is that it standardizes any anomalies to follow a mean of 0 and a standard deviation of 1. Now, for example, you were studying 10 football strikers and you found out that out of these 10, 7 of them were actually performing badly. Now this will lead to a curve which is skewed towards the right? Majority of them have been performing badly, so the curve will have a format like this. But what you intend to have is a format which is representative of how things are in the world, and how things are actually like this. Then majority of them are going to be in the middle. But since your sample, again emphasizing on the word sample, is only of 10 people, the curve comes out to be like this. And since we trust more of the population, which is the true end, we would like this graph to turn into this graph. Now, in order to do that, the mean has to be 0 and the standard deviation has to be 1. In order to achieve that, what we have is a z-score. A z-score. Now, a z-score is the conversion or the conversion of the x distribution, that is the distribution concerned with the sample being converted into the z distribution, which is the distribution of the population. So the formula of converting a said x to z is that we subtract the mean of x and divide it by the standard deviation of x to standardize it in such a way that the mean becomes 0 and the standard deviation becomes 1. Now this all sounds a bit complicated, but we do kind of aesthetically understand why we need to follow a standard normal distribution. And the reason is that specifically we want to study something which is closer to how things are in real life, which is a population based normal distribution, right? And that is why we have to follow the normal distribution per se. In the next video, what we'll do is we'll calculate a certain amount of sums so that you're quite well versed with how to follow a normal distribution and how to solve these distribution of sums. I hope you understood the intricacies of normal distribution. If not, I'm free to take any questions. You're free to shoot it away. Thanks and have a nice day. Meet you tomorrow.